Hi everyone, it's Dr. J with the finished version of the selection sort program. Remember in part 2, we simply did the outline of it and then we filled in the functions in part 3, and I'm going to explain them and document them. Let me remind you that this program has a lot of features that previous programs that we looked at did not have. I'm going to let Ali read the comments about this program before we get started documenting it and explaining it further. Ali, you want to say hello to everyone?
Hello.
Okay, want to read this comment?
Sure. Like starting from up here?
Yeah.
Okay. This program will sort an array of integers using the elementary sorting algorithm selection sort. We will use some helper functions with pointers. We will also incorporate pointer arithmetic to step through the array. First, we define function prototypes. Authors are Dr. J and Rajan.
Okay, thank you. And what are the function prototypes? You want to just read them?
Function prototypes are going to be the first four here, lines 10 through 13. Void, swap, int, I guess that's multiplication.
A pointer.
Oh, a pointer, sorry. Void, swap, int, pointer, then int, pointer.
Let me just put a little comment there. Prototype for swap function. Prototype. I'm going to put line comments everywhere. For swap function. Okay,
And,
next one.
Integer pointer to find the position of the lowest.
Yeah. Prototype.
Pointers once again.
Yes. Prototype for function to find and return position of lowest. Okay, the next one.
Prototype.
What did I do here? I gotta move the things over here. Whoop. Maybe I should just go to another line here. Yeah, find and move this over so it's less confusing. Okay, the next one.
And then it's a prototype to sort.
Yeah,
with the array and
a special algorithm called selection sort, right?
Right.
All right. So that one we have n-1 passes if there's n elements, and we keep looking for the smallest, until we process all the elements of the array. So this prototype for the sorting algorithm. And we're just passing the array and how large the array is, right?
Mm-hmm.
Okay. And the last prototype?
Last prototype to print out the list of
Yeah,
the above things that we're
and whenever we're
trying to
just doing printing, we always do just a void function. So prototype to print out the list. Actually, to be more precise, to print out the second parameter says how many elements, but it's fine. Leave it alone. All right, so now we're looking at main, and the first thing we do in main is declare and define a list, right? An array. All right, so declare and initialize an int array with 16 of my favorite numbers. I really have a lot more than 16 favorite numbers. I use them all in Lotto, but I've never won.
Oh.
So maybe I should try new favorite numbers.
New favorite numbers.
Okay. let's see out the array before selection sort is just a little line of output that lets us know what we're printing when we call print list right here. So let's put another comment here. Print the list, one element per line, and the 16 is the length of the list. So I could say print the first 16 elements. In this case, that's all there are. Elements of the list, one element per line. And now this is a call of the function to do so, right? This to sort. Sort the list in ascending sequence. So our main is outside of the comments, actually just a few lines of code. All the work is being done really in selection sort and print list. Print list is just showing us that we're right, that we did the sort right. So see out for the list after selection sort, and again, the comment is already here. It should be in ascending sequence, right?
Yes.
So it makes sense to look first at print list because it's the first function that we talk about, that we call in main, and then we'll look at selection sort. So let's look at print list before we look at any other function. Print list is first parameter is an array which we could have called anything, right? So it's a local parameter to print list. We could have called it B, we called it A. Let's just be different, call it B, just to show that it didn't matter. It doesn't have to have the same name as in May, as in main. Yeah.
Didn't realize.
Yeah, so let's call it B, because A is being passed into B. And N, we didn't use that before. That's a good, we've been using N for the length of the list all along, so we'll stay with that. So let me just fix these remarks. You want to read this remark? Precondition, postcondition.
The precondition is that the array B now has been filled with at least n integers.
Right.
Postcondition is that the output the list one to a line.
Right, one element. I should put
Or one
element.
element, all right.
Clearer.
One array element.
Yeah.
I guess.
Yeah.
I don't know.
Yeah, sure. One array element, sure.
Maybe that's
Redundant?
maybe. Kind
It's fine. Better to be redundant than not clear, right?
Yeah.
All right, so here we have the logic of print list, and it's just one line of code. You want to read the one line?
For let's see, initializing the integer I equals 0, to
I less than
have
n
it
is a condition.
less than, and then increment the I.
Right, so we see out I, which is the position of the element, followed by a colon, followed by the value of the element, B of I, and len. So that should work just fine, and we did test that in part 1, and it certainly worked. So now the next one in main, there's only one more function that we called in main. Select sort. Yeah, so we should look at that next. Okay, select sort. This looks a bit more complicated, but actually not. How many lines of code is it? Not many. It's just
3, 4.
Yeah, the for statement
or total.
And the swap statement. Actually, two lines of code, right?
Okay.
Oh, 3. The P++. Okay, so let's go through this logic. Avoid select sort, that's the name of the function. It's expecting an end pointer. I called the end pointer P. I could have called it PTR maybe for clarity. But, you know, I don't like to type too much. And int n, where n is the number of elements that we want sorted from the list. And we should write a precondition, I guess.
Okay.
Precondition every function should have a pre and post condition. Precondition is that P points to the beginning of the array, right? P should point to the array, or beginning of the array to be precise. The 0th element of the array to be very precise.
Yes.
Yeah. So that's the precondition. Of course, I need to put a little comment, right?
Yeah.
All right. And the post condition, also, the array should be to the of the array, which should be filled, which should be filled. Otherwise, we don't want to sort garbage, right?
Right.
All right.
That wouldn't be fun.
No, I mean, we've done it before, but rather not do it again. Post condition. The post condition here is that what? The array will be sorted.
Yeah.
The array will be sorted, or to be precise, the n elements pointed to by P will be sorted. The array will be sorted from low to high. Okay, and what we're doing is using pointer arithmetic. So we have a for loop that says for I equal 1, I less than n. Now the reason we're doing this is counting the passes. If you have 16 elements, we need 15 passes. If you have n elements, we need n minus 1 passes to completely sort the array. So this is clearly n minus 1. Beginning with 1, ending in n minus 1 is n minus 1 elements. So what we do is we're assuming that the 0th, that the element pointed to by P is the low. No, we're not assuming anything. We're assuming that the element pointed to by, this is a little tricky here. The element P plus plus is incrementing P to point to the next element of the array, to element number 1. So if we swap P with find position of low P n minus 1, I'm not sure that we're ignoring the first element. So that's actually a little boo-boo. So let's fix that. Take out this plus plus. We don't do that at the beginning of the loop. So we're swapping P with the position of low P n minus 1. That's much better. Okay. Yeah. And then we go ahead and increment P. We could do that. We could do that in one line, I guess, if we really get sneaky. Okay, so hopefully that'll work, maybe. I mean, this program was tested, but I didn't pick up the error because 12 was in the 0th position, and 12 is the smallest element. So just because I skipped that element, it was still good. So you know what? Let's try running this before we continue documenting. Make sure the change is a good change. No, it put 12 at the end of the array.
Oh.
Clearly not a good change. That is strange. So it swapped 12 with the 15th element. Huh. The whole thing is unsorted now.
Oh yeah. Just
Yeah.
because of the people.
Yeah. Okay.
Weird.
It's clearly something wrong. Let's try incrementing P before pre-increment. Maybe that's going to work. I think that'll work. Can you have fingers to cross?
Yes.
Okay, to cross a couple of fingers. It worked.
Oh.
You see, your fingers crossed. That did it. All right, so that's better. Better logic. Okay, and also we saved the line of code.
Mhm.
We got rid of a left squiggly and a right squiggly, and you know how much I hate left and right squigglies.
Yeah.
So one squiggly less, two squigglies less. So the idea is we're swapping the first time through the loop, we're swapping the 0th element of the array with the position of the low from the one element to the, no, well, beginning at the one element for n minus, for n elements, for n minus one elements. Let's look at the position of low. Int asterisk low equal p, low equal p, but the p is the one element. So I think this worked by accident again.
Oh.
Yeah, only because the 12 was the lowest in the, yeah, let's change that 12 and you'll see that it won't work.
Oh. Okay.
Let's change that 12. This is called debugging. Let's just change the 12 with the 35. And I bet you it does not work now.
I see.
35
the
will,
first
I think 35 will appear as the smallest. Yeah.
Okay.
Yep, 35 appears as the smallest, but the good news is the rest of the array is sorted.
Fine. Mhm.
Yeah. So we're getting closer.
Okay, so
Close, but no cigar. So let's fix it for real. Okay, so the idea is, we want to begin, we want to, it's tricky, a little tricky, but we'll get it. Okay, the fact that I'm using P here and then changing P here, I think it could be the problem, maybe. Swap P with parentheses. Yeah, that's probably the problem. Let's just leave that in there. We'll do that increment down here and put the squigglies back. I hate to put the squigglies back, but I don't see any way around it. Probably is a way around it, but for now I don't see a way around it. So we'll just do it this way, and I believe this should work.
okay.
All right, let's try it. See, even programs that you test that look like they're working may not in fact be working.
Okay.
That's the lesson to be learned here.
Oh.
But now it's not
No.
working.
Oh. But did you want to try the decrement before the peak or the increment before the peak?
Well, it worked up until 29. It messed up with 29, right?
Yeah.
Yeah, so let's see why. That was the last element of the original list. It didn't do enough elements. It didn't go far enough in the find position of lowest. So it should go one more. Find position of lowest. Should go one more. That's easy to fix. Less than or equal. Correct?
Oh, okay.
I would think.
Yeah.
And then it should fix it.
Oh, good.
Perfect?
Yeah.
Okay. So now let's get back to our documentation. So this is a combination documentation, debug session. We showed some valuable debugging techniques and how you can get tricked into think your program is perfect when in fact it is not perfect. So we could test with other data, but I'm pretty happy now that it is definitely working. So let's go back to documenting. So now the documentation is, this is good, count n minus 1 passes, swap the element pointed to by p, swap int pointed to by p with the lowest, which find position of low is going to find for us. And then increment p. It looks like we're incrementing by 1, but we're really incrementing by the length of the integer, by the size of an integer. Increment p by size of an integer, whatever that is, 2, 4, probably 4. Okay, so that's good. Now, this is calling find position of low, right? So, and it's calling swap. So we have to look at 2 more functions and document them. I guess swap first. That's the easier one. And then this is called a nested function call because within swap, we're calling another function find position of low. So this is a nested function call. Let's put a little comment. Below is a nested function call. And that's pretty powerful coding. It's about as powerful as it gets. Okay, what are we up to now? We want to look at swap. Where's swap? Swapper. Oh, there you are. Well, this is just 3 lines of code. We have 2 pointers, P and Q, that are pointing to integers, right? So that would be the precondition. Let's stick with precondition, postcondition. So the precondition is P and Q point to 2 distinct, doesn't have to be distinct, to 2 integers. Okay, and what we do is store the int pointed to by P in T, right? And then we simply assign the integer pointed to by P, we assign that to the integer pointed to by Q, and then we restore Q from T. So I think the rest is pretty clear. And finally, let's look at, we didn't do the post condition. Post condition. The post condition is what?
Swap the 2?
Yeah, the contents of P and Q.
Okay.
Contents of the integers pointed to by P and Q. Will be swapped, exchanged, whatever. What about P and Q? They will remain unchanged, right?
Mm-hmm. Just swapped.
P and Q remain, the contents of P and Q remain unchanged. It's only the integers pointed to by them.
Mm-hmm.
P and Q remain unchanged. Okay. What's left? Just one more function? That's the toughest one of them all, yeah. That's the toughest one of them all. Okay, so we're returning a pointer that points to the position of the lowest element in the array, but not the entire array. This first parameter says where to begin looking. And the second parameter says how many elements should we look for in total. So if we begin in the 0th position, we're looking at n elements in total, 0 through n minus 1 elements. And if we're beginning in position 1, we're looking 1 through n, or n minus 1 elements, right? All right, so That's exactly reflected in this for loop. The first line assumes smallest at the beginning of the pass, right? And the loop itself is stepping through n minus 1 elements, right?
Mm-hmm.
From 1 to n is n minus 1 if you count 1. No, if you count 1 and you count n, it's n elements. N elements we're looking at. N elements. All right. P plus plus, P plus plus. That increments P by move it to the next element of the array. And now we're asking the question, is that element smaller than the lowest element? And if it is, then we change the pointer low to equal the pointer P. So it points now to the lowest. I'm not sure about this equal sign. Let's just check and see if it works without it. No, so we do need it. Okay. For some reason, I wasn't sure. Okay, so now I think we have everything pretty well documented for the most part, and hopefully pretty well explained. But this is something that you have to look at over and over again because it's different than the program in the book. The program in the book has a nested for loop and is done without pointer arithmetic. So this has a lot of new concepts. And thank you very, very much for your help, Ali. I couldn't have done it without you. Thank you.